All right, so get ready, because today we are going to decade your breakfast.
Yeah.
We're cracking open the science of cooking eggs. You know, that everyday miracle of turning liquid goo into solid deliciousness.
Right.
Turns out there's a whole world of chemistry happening in that pan.
Yeah.
And you're about to become an egghead about
That's
it.
right.
Okay, so let's just unpack this a little bit.
Yeah.
What's actually in a raw egg besides, potential breakfast?
Well, an egg is basically a chemical cocktail of proteins, fats, and water.
Okay.
But the real star of the show when it comes to cooking is the protein. It's the protein that goes through the most dramatic transformation when you crank up the heat.
So those tiny protein molecules are getting a heat makeover.
Yeah, kind of.
Do they, hit the gym or something?
Sort of. It's called denaturation.
Okay.
And it's more like they're letting loose on the dance floor.
Uh-huh.
See, heat causes those tightly wound protein molecules to unfurl,
Okay.
kind of like untangling a really knotted up headphone cord.
Ah, so instead of these neat little coils, they're all stretched out and free.
Exactly.
It does sound like my cow party.
And once they're all spread out,
Yeah.
I've got all these reactive sites exposed that were hidden before. Think of it like suddenly having a bunch of Velcro patches that were previously tucked away.
Oh, okay. So now things are going to start sticking together.
Yes.
Is that how we get from runny egg to, actual food?
You got it.
Like that?
That's what we call coagulation.
All right.
Those unfurled proteins with their little Velcro patches exposed, they start to bond with each other, forming a network.
Okay.
And it's this network that gives cooked eggs their solid texture.
Wait, so it's like a giant protein mosh pit happening in my frying pan.
Yeah.
All these molecules bumping into each other and clinging on.
That's actually a pretty good analogy.
Really?
And the longer they mush, the tighter that network gets.
Oh.
That's why a soft-boiled egg is still a bit runny.
Right.
The proteins haven't had as much time to bond.
Uh-huh.
But cook it longer, and you get a hard-boiled egg where those proteins are locked in tight.
Okay, that's a game changer.
Yeah.
So by controlling the heat, I'm actually controlling how wild that protein party gets.
Right.
And therefore, how my egg turns out.
Exactly.
Mind blown.
But there's more to the story. Remember those fats and sugars we talked about?
Uh-huh.
Well, they play a key role in the Maillard reaction, which is what gives cooked eggs that delicious browning and those amazing savory flavors, especially in things like omelets and baked goods.
Oh, yeah, the Maillard reaction.
Yes.
Isn't that what makes steak taste so good, too?
That's right.
Or gives bread that crusty brown top?
You're exactly right.
Yeah.
It's the same reaction happening across all sorts of foods.
Wow.
It's basically a chemical tango between proteins and sugars when they get heated, creating a whole cascade of complex flavor molecules.
So that perfectly browned omelet,
Yeah.
that's not just about looking good, it's about maximizing that Maillard magic for the best possible taste.
Exactly. And it
Okay.
all comes down to understanding the chemistry happening at a microscopic level.
So you're saying that by knowing a little bit about protein parties and sugar tangos, I can become a better cook?
Absolutely.
I'm into it.
It's about knowing why certain techniques work the way they do.
Yeah.
And speaking of techniques, let's dive into how different cooking methods can actually manipulate these reactions
Okay.
to create a whole spectrum of textures, from those runny yolks to fluffy omelets.
Okay, I'm ready to unlock the secrets of egg mastery.
All right.
Bring on the next
Well,
guy.
before we go there, let me throw in a quick fun fact.
Sure.
Did you know that sometimes even the appearance of something can impact food science?
Okay.
Like back in the 70s, the FDA banned a perfectly safe red food dye.
Huh.
Just because it looked too much like a dangerous chemical.
Wait, seriously?
It's true.
They banned it just because it looks scary.
Yeah,
So even color could be a factor in this world.
it's true.
Huh.
Which leads to another interesting question.
Okay.
What else might be lurking in our food that we don't even realize?
Okay, lurking's a strong word. It makes it sound like there's something sinister in my food.
Right.
Are you trying to tell me my breakfast is out to get me?
Not quite.
Okay.
But you might be surprised to learn that the FDA actually sets these things called action level
Uh-huh.
for things you wouldn't expect in your food.
Okay.
Like insect fragments and rodent hairs.
Hold on.
Yeah.
Bug parts and rodent hairs. You're saying there are literally bits of hue in my food. And the FDA is cool with this?
It's not as bad, it sounds.
Okay.
These action levels are for things that are basically impossible to totally eliminate.
Okay.
We're talking about tiny, unavoidable traces.
Okay, so we're not talking about like a whole leg of a grasshopper in my cereal.
No.
But still,
Right.
why allow any amount of that stuff?
Yeah.
That just seems kind of gross.
That's where the science comes in.
Okay.
The FDA sets these levels based on tons of research to make sure they pose no threat to your health.
So you're saying a little bit of extra protein is statistically inevitable.
Yeah.
And more importantly, not actually harmful.
Exactly.
Okay.
And these action levels are often way stricter than what you'd find naturally.
Really?
It's all about making sure our food is safe, but also realistic.
Right.
I mean, imagine trying to get every single bug part out of a giant wheat field.
Yeah, good point. I guess it's more about managing those levels than aiming for absolute purity.
Right.
Which is probably impossible anyway.
Right. And this idea of managing what goes into our food actually brings us to another interesting area. Food additives.
Oh, yeah, food additives.
They often get a bad rap, but many of them are crucial for keeping our food safe and tasty.
There are so many strong opinions out there.
Yeah.
How do I even know what to believe?
It's true. There's a lot of fear-mongering out there.
Yeah.
But remember how we talked about controlling those protein reactions in the egg?
Uh-huh.
Additives can do the same thing, just on a larger scale.
Okay.
Preservatives, for example, stop spoilage and keep harmful bacteria from growing.
So it's not just about making food look prettier or taste a certain way.
Right.
It's about actual safety, too.
Absolutely.
Okay.
Take antioxidants, for example.
Uh-huh.
They keep fats and oils from going rancid.
Right.
That's important not just for flavor, but for the nutritional value, too.
Okay, so not all additives are evil.
Right.
But how do we know which ones are actually safe?
Yeah.
Does the FDA just let companies put whatever they want in our food?
Not at all.
Okay.
They have a super rigorous approval process.
Okay.
Companies have to prove that an additive is safe and does what it's supposed to do.
So it's not just like some mad scientist in a lab throwing random chemicals into a vat and saying bon appetit.
Definitely not.
Okay.
They have to show how it's made, how it interacts with other ingredients,
Right.
and what the potential risks are.
It's a whole science in itself.
It is.
This is making me think about that rid food dye you mentioned earlier.
Uh-huh.
Was that a situation where they just didn't do enough testing before it hit the market?
Actually, the red dye itself was totally harmless.
Okay.
They banned it purely because it looked like another chemical that was dangerous.
Really?
Yeah, kind of a case of guilty by association, I guess you could say.
Wow, that's wild. It makes you wonder what other surprising factors come into play when it comes to food and science.
Yeah, it's a good reminder that even in science, things aren't always black and white.
Uh-huh.
And it highlights why it's so important to understand the complexity of these systems.
It's funny, we started off talking about cooking eggs, and now we're diving into the world of food safety and additives.
Yeah.
It really shows how food and science are totally intertwined.
Absolutely.
Uh-huh.
And speaking of science, there's another fascinating concept I want to touch on.
Okay.
That often comes up in drug development.
Okay.
It's called polypharmacology.
Polypharmacology. Okay, that sounds intimidating.
Yeah.
Break it down for me like a back in high school chemistry class.
Think of it this way.
Okay.
Imagine a drug that's like a master key.
Okay.
Able to unlock several different doors in the body.
Okay.
That's essentially what polypharmacology is all about.
Right, okay.
One drug interacting with multiple targets.
So instead of having a different drug for each specific problem, we're talking about drugs that can multitask.
Exactly.
Like a Swiss Army knife of medicine.
Exact. And this is super relevant when we're dealing with complex diseases like cancer, where multiple things are going wrong at the same time.
That makes sense. It's like attacking the problem from all angles at once.
Right.
But wouldn't that increase the risk of side effects?
Yeah.
It sounds like it could get messy.
That's a valid concern, but here's the cool part.
Okay.
Polypharmacology can actually create a synergy.
Okay.
Where the combined effect of hitting multiple targets is way stronger than just adding up the individual effects.
So it's like a superhero team-up.
Yeah.
Like each hero has their own strength, but when they work together, they become unstoppable.
I love that analogy.
Yeah.
And when it comes to drugs, this means we could potentially treat diseases more effectively with lower doses, which could mean fewer side effects.
Wow, that's incredible.
Yeah.
So are scientists purposely designing drugs with this polypharmacology in mind now?
Totally.
Wow.
It's becoming a big part of drug design. Scientists are using it to develop therapies that are more targeted and hopefully more effective in the long run.
It sounds like we're moving away from that old one drug, one problem model and towards a more holistic approach.
Right.
Kind of like how we were talking about the whole egg, not just the protein is important for flavor and texture.
You got it. It's about understanding the bigger picture and all the different players involved.
Well, I have to say, this has been a seriously eye-opening conversation.
Yeah.
We've gone from the chemistry of a simple fried egg to the complexities of drug development.
It's been a blast exploring all these different facets of chemistry with you.
Yeah.
Hopefully, our listeners are feeling a little more sciencey about the world around them now.
Absolutely.
Yeah.
We've learned that chemistry isn't just some boring subject from school.
Yeah.
It's happening everywhere, all of the time.
It is.
And it's what makes our world tick, from the food we eat to the medicines we take.
And as we keep making new discoveries and pushing the boundaries of what we know, who knows what amazing things we'll find out next.
That's the exciting part.
Yeah.
There's always more to learn, more mysteries to solve, and more potential to unlock.
So to our listeners, we'll leave you with this.
Okay.
The next time you're cooking, really think about those chemical transformations happening right in front of you.
Yeah.
It'll make that meal taste even better knowing the science behind it.
Thanks for joining us with this deep dive into the world of chemistry. Until next time, stay curious and never stop exploring.
Thanks.